you're watching the Green Network Summit, part of our year-round DSP Leaders coverage. I'm Guy Daniels, and today's discussion opens the summit with a look at how we ensure a sustainable evolution to the green network. For example, is a gradual evolution the best approach, or is more urgent action now required? And how can telcos break the dependency between traffic volumes and energy consumption? And how will AI contribute towards all of these efforts? Well, I'm delighted to say that joining me on the programme today are Terje Jensen, who is SVP Network and Cloud Technology Strategy for Telenor, Mark Gilmour, Chief Technology Officer at ConnectiviTree Europe, Nigel Stephenson, Director Market Development EMEA for the Software-Defined Edge Division VMware, and Francis Haysom, Principal Analyst with Appledore Research. Hello everyone, good to see you all for this first summit of the year, and we have lots to talk about today. So first of all, I'd like to ask what you all think is the most effective route towards the green network and better energy efficiency. Is it a gradual introduction, as we've just mentioned, or are more radical steps required? Nigel, can we come across to you for your views first?
Yeah, sure. I think we'd all love to be able to throw a switch and make everything right. The reality is it's a very complex environment that telecoms operate in. It's also a regulated environment. So there are considerations that have to be taken into account as to how you approach this. That's not to say that I don't think you can make some quick early steps, and the important thing is to start the process. So two things I would suggest in terms of making that start. One is building the plan, and the approach I think we need to take is we need to first of all benchmark, and then we need to look for ways to improve, and then we need to try and implement those improvements and then remeasure and then repeat that cycle. I don't think this is an absolute thing where you go from A to B. It's a continual improvement, and there's lots of ways we can start that process. And that is being aided by things like better instrumentation, being able to bring in more factors, not just in the IT side of the business, but also in things like power supply, aircon, and so on that the data centers rely on. But the other important factor is risk, especially in the telecoms industry. Risk is a big issue. And I think the industry needs to rethink its attitude towards risk. So as well as looking at where you are today, benchmarking the installation, and then looking for where to improve and then remeasuring, we also need to look at where we can make the impact first, and that really comes down to risk. So there's a whole conversation around where are the highest risk applications, where are the lower risk applications, what can you do first. That needs to go in line with the development of the plan.
Great, thanks very much, Nigel. So it's like a continuous learning feedback here as we implement and learn and then re-implement. Mark, I'll come to you in a second, but Francis, I want to come to you next and get your views as to the approaches that perhaps you're seeing.
Yes, I think I agree with what Nigel is saying. I think this has to be introduced. The regulatory industry is important. I think one of the things we need to work on is to understand that it's not necessarily completely an either or. There will need to be some quite radical steps. We need to explore those radical steps. In fact, telcos are actually quite good at exploring those kind of radical steps, whether it's it's networks breathing or closing off in that area. But there needs to be something which we see in quite a lot of things, not just in the energy area, but in the whole area of the innovation area, is how do we bridge between those sort of trials, those proof of concepts, and how do we make them get actually into scale in the network? Because there's kind of a chasm between those two things. Those two things there, and we saw that actually at the AI conference before December with TelecomTV. That there's a very distinct difference between what energy saving using AI is doing in terms of proof of concepts and the like, and what the mainstream business was doing in terms of largely energy arbitrage. So how can we link those two together? I think it's going to be an important strand of actually getting this evolution right.
Yeah, thanks very much, Francis. Yes, as we did here before Christmas, plenty of POCs and lighthouse projects, but bridging that gap is it's something that's going to require a lot of effort and thought and resources. Mark, let's come to you next, and then we'll go to Terje. But Mark, we'll come across to you for your views.
Thanks, Guy. I'm of the opinion that this process, it needs to be systemic. It needs to be across the board. Whether it's radical or gradual, I think will depend a little bit upon the mentality, the kind of the culture within the company. But ultimately, it's got to be continuous. It's got to be sustained. It's got to be keep moving. My concern, my worry is that a lot of the momentum behind, for example, energy efficiency was driven by a bottom line discussion because energy prices soared so high. When those energy prices return to a more normal level, or whatever that normal is, but when they return to that, or as they return to that, it's making sure that this agenda item continues to feature across the C-level, across the executive level, and down into all of the areas. I'm pretty hopeful and pretty confident that it will. I think we've crested that, but there are some radical decisions that need to be made, or movements that need to be made. And I think that some of those are cultural and operational model sort of approaches, which I'm sure we'll cover either later in this broadcast, but certainly across the summit. And it's those sorts of processes, those sort of things that have to become systemic, and it become part of the fabric of telecoms. Actually, in the same way that we talk about bandwidth expansion and growing usage and things like that, we have to also talk about and keep energy efficiency, productivity. The green network has to stay in that same dialogue and just become part of the table stakes of telecom. And I think we're in a good position to be able to continue that. We've proved so far that we can, and I think we need to then move that forward.
Great, thanks, Mark. And like Nigel was talking about risks there, I guess another risk is that we deprioritize the importance of this work, as you explained there. Well, we'll come back to Nigel in a second, but Terje, let's introduce you to the conversation now and get your thoughts.
Yeah, thanks, Guy. And I broadly agree with everything what was said, but I was just wondering, so in my mind is a combination of incremental features, and a number of features are already present, actually implemented in the equipment. So it's more, in many cases, more a matter of activating this, and then of course be on top of the risks and what are the consequences using energy efficiency features. So for example, in the base stations. But I think if you really want to take a step, or maybe two steps back on the green network, it's of course a question about consuming energy efficiency in an efficient way, but it's also about energy sources. And then, of course, the missing link there is connecting these energy sources with the energy consumers. So not to forget about, the green energy sources as well, which tends to be in some cases a bit more, big contracts, for example, on renewable energy and power purchasing agreements, for example, when it comes to windmill plants or solar energies and those kind of things, which is quite an important part, I think, on the energy budget for an telco. Because it's not, of course, not only energy as such, but it's also the clean energy or the green energy, if you want, or the climate impact of that. Then, of course, it's also focusing on the big energy consumption, switching, for example, in Telenor case, roughly 90% of the total energy consumption is referring to the network. And out of that, it's roughly 3/4, which is in the base station part of it. So it's easily to do the calculation on what matters the most. But just not to forget about the energy sources on the calculation, in particular, like a footprint, what Telenor has in Europe and Asia, and also in Asia in particular, when not all the energy sources are that clean, a lot of diesel, for example, and so forth. So I think we should bring that into the calculation. Then, of course, it's not only energy on the base stations. We see that the energy consumptions in the data centers are growing quite a lot these days. So what can we do, for example, with the surplus heat there? Can we use it for remote heating of apartments and so on? So we're also engaging with partners to make that happen. Say, for example, in Norway with the great green data centers. So it's a lot of different moving parts here, and I think it's important to be on top of all these kind of things. So put all these pieces in the overall puzzle. I think Mark was referring that we need to orchestrate this and make sure that we have a structured approach. So that's quite important, as I see it, to really get the benefits out of all these initiatives.
Yeah, thanks very much, Terje. Because as you say, there are many elements in this puzzle that have got to come together. Thanks very much, Nigel. I promise to come back to you. You want to make some additional comments?
Yeah, just picking up on a couple of those points, and maybe also making the point that just because this has to be and it needs to be continuous and sustained, as Mark says, but it doesn't mean to say that approach isn't going to deliver rapid results, right? Because if you look at the typical telecoms environment, it's a very distributed environment. There are plenty of places where you can make small incremental improvements, but then they're deployed at scale. So the overall effect can be very large. If we look in at the core of the network, then in data centers, we see in today's data centers, a lot of workloads or a lot of infrastructure is provisioned for capacity, right? For maximum capacity, which is not necessarily needed. This is where the risk element comes in. Where are you prepared to put hardware to sleep, or to reduce the amount of capacity or the number of cores that you're offering to an application, for example. Now that's a sort of a risk calculation, but the reality is, if you look at a lot of these applications that are sort of designed for peak load, they could be running at sort of 25% efficiency or 25% usage if you look at things like CPU capacity. So there's lots of opportunities once you get your head around how to assess the risk of various application types, where in the core of the data center you can make a big impact quite quickly at relatively low risk. And then if you look at the trend towards edge computing, the changes happening in the RAN, those are areas of the network that are deployed at massive scale. So if you can make small changes there, it still has a big impact relatively quickly. So we shouldn't sort of, I don't want to suggest that a gradual implementation in any way means that it's not a rapid effect. So that's one thing. And the other thing is just the scope for innovation, as again has been touched on. This is way bigger than just the IT piece. And it's also the operational practices can change. As an example, which I think is great, we're involved in, we have a utility company that is forecasting how green its energy is going to be at a certain time. So even green energy suppliers are not 100% green all the time, but they do have, based on things like weather forecasts, they do have the ability to predict when their energy supply is going to be more or less green. If you then combine that information with shifting workloads in time and space, so perhaps workloads that don't have to operate at a particular time of day, they can be, batch processes, things that can happen, at different times. Those can be moved in time to match when your energy supplier is telling you they can supply the most green energy. That's one way of looking at sort of being innovative in how we address the problem. Another way of doing it is, if your footprint permits, literally moving workloads from one data center to another if one data center at a given time is actually running off better green energy than the other. So there's ways you can move applications in time and space matched to things like data from your energy suppliers, that then through automation and advances in some of those techniques around the network, you can really start to make some significant impact, either simply by reducing the overall energy or by making sure you're using greener energy when you do need to consume it.
Great, thanks very much, Nigel. Well, there's obviously a lot of smart thinking being applied to this problem, but I want to come on to one of the long-held beliefs has always been the more traffic you generate, the more energy you've got to use to support that traffic. We're hearing, though, that's not necessarily the case. So what can telcos do to disconnect energy increases from rising traffic and usage volumes? How is it possible to break this historic dependency? Terje, are you able to break this dependency over to Telenor?
Yeah, well, I can give you one example, and not to claim that this will be last forever, but an example I'm going to refer to was just the years before we launched 5G. So just to keep that in mind. But the last that means that the 5 years before 5 years period before 2020 2021. During those 5 years, we were actually seeing a 200% growth in the traffic. This is across the total footprint of Telenor. And despite this 200% growth of traffic, we managed to keep the energy consumption flattish, which is kind of contradicting, I think, what you said, that it doesn't have to be a strict correlation between the demand and the energy consumption. And the way to do this is actually requires a combination of hard work, very data focused or fact based, decisions and experimenting. And being very forceful, shutting off legacy equipment and also shifting traffic a bit forceful to the newest technologies. And then there are quite a lot of smart people, around in the group on coming up with ideas and also validating what works and what maybe are too risky to replicate. So I think there are a lot of things you can do in order to fight this truth that there's a strong correlation between traffic demand and energy increase. So just a couple of examples, if I may. So we see that, for example, and we are quite forward-leaning in introducing new technologies and swapping old technologies. And we see that every new technology generations improve the energy efficiency quite a lot. Then, of course, we also see that there are no chipsets coming, and you can also control them on into sleep mode, for example, and also the frequency of their working, for example. So there are quite a lot of benefits to get out of the newest technologies. What we also see, I think Nigel was referring that when we optimize the resource use, putting increase the load and also route the traffic and considering the energy into that, the way we are managing the traffic, we also get quite significant benefits on the energy bill in that sense. So one example, of course, is the local breakouts and local handling of some of the traffic, where we have some use cases where there are high definition cameras, generating typically something like 10 or 20 megabit per second each camera. And a lot of that information coming from the camera is not really containing any useful data. So we can just kill maybe 95% of that traffic, almost very close to the camera, meaning that a lot of that traffic will not be carried, and that will also have a positive effect on the energy consumption. So I think that's some of the benefits we have seen. Another thing is, of course, is to shift traffic to the newest generation. I think also Nigel said that. So try to move more of the traffic onto 5G instead of 4G, for example, and definitely 5G instead of 2G and 3G. So we have been sunsetting quite forcefully 3G, for example, in several markets to make this happen. So I think there are quite a lot of things you can do, and all these smaller things or bigger things adds up, of course, to a positive consumption of the energy or increase of the energy efficiency. So I think there are quite a lot of things to be done throughout the industry, actually, on these kind of things.
Great, thanks very much, Terje. As you say, it's a cumulative gain, lots of small changes, lean into the latest efficient technologies, apply smart thinking as well. I'll come to Francis in a moment, but Mark, let's come across and hear your thoughts about this dependency between energy use and traffic volumes.
I agree there with what Terje was saying there about the generational change, that as you move to latest technology, then absolutely we can start to really gain benefits there and maintain that energy consumption for higher capacity. We've seen that over the last 25 years and more in terms of the telecom environment. The challenge to that, though, goes along with the risk question or the risk point that was brought up by Nigel, which is you've got to take that risk to sunset previous technology versions and move people off, and I think we've got better at that over the last 5 years or so, probably out of necessity as well, operational necessity and cost necessity. That makes a big difference. But you only get the full benefit of moving to newer technologies in terms of the power consumed per bit, for example, which it's a difficult metric to swallow, really, because it only really benefits when you are highly utilizing that network, driving traffic across it. Then you get the power. The power, overall power consumption is more efficient. There are needs to have just to have the lights on in certain parts of the network. I think we're getting better at moving towards the 0 bytes, 0 watts sort of approach. That's fantastic. I'd love to see that sort of capability come into my area of the network, which is the high capacity backbone side of things. We're not there yet. There's still some technology development that needs to be able to do that, to be able to really utilize on that. So really the approach needs to be, how do we get better utilization into our networks to then, on this newer technology, to then maximize the power efficiency that comes inherently in new technology. You've got to be able to do both things there, and I think that's pretty fundamental to being able to disconnect this linkage. That's really one gigantic area in this space, I think, of because I think it's folly to believe that demand is going to subside in order to keep energy levels down. That's just not the game that we're in. So how do we benefit by leveraging the new technology with better utilization and fulfilling that? And that requires different models, different approaches, and a different way of thinking, and in terms of how we approach the network, how we approach the industry, how we collaborate and work together as well.
Great points, Mark. Thanks very much for those. Francis, let's hear your thoughts about this. It's a very new way of thinking, really, about how we deal with the ever-increasing data traffic levels, which, as Mark says, they're not going to be falling.
Yeah, I think there's two things. I come back to something Terje said earlier, which I think is really, really interesting, which is we're the ability to think about attaching your energy value to the reduction of how much traffic you're actually sending. He used the example of security cameras, etc., and to tie your value to the wider scope of what your energy usage is enabling. So we've talked largely, I think, to coin some terms, we've largely talked about scope 1 usage, which is the network, the energy we use in the network. But there's a whole set of energy that's associated with scope 3, which is the consumers of our network. And if there's anything that we can be doing, it may be that we're consuming more energy in the network, but if we can trade it for what we are doing better for the consumer, that may be a way in which we square the circle of increasing capacity, and attach ourselves to value, which quite often actually uses far less bits. Sort of transmission of metadata is much more efficient, but it doesn't use as many bits. Transmission of control is much more. It's an on-off or something like that, but it has much higher value and should enable us to actually attach ourselves to higher value in energy for the consumer. And I think the second thing is looking at the monetization models for that. How do we expose the use of energy in our network as something that is saving something in a consumer's network? Maybe also the area in which we can look to see different models here.
That's a very interesting angle there, Francis. Thanks for that. And Nigel, let's come across to you as well.
Yeah, I just wanted to pick up on something Francis said, and something I was thinking about, which was a lot of this is about instrumentation, and we can get a lot of data and telematics from the hardware itself. We can manipulate that in software. We as a company do that in the IT space, and we're now starting to develop dashboards that can be fed with data from other sources outside of the IT space. to give an overall picture, and that I think is becoming increasingly important. Some of the switches we can throw are not necessarily new. They're things like we've been able to do for a long time, moving workloads, starting workloads at different times of day, reducing the number of cores for an application. These are not necessarily always new switches or levers to pull, switches to throw, levers to pull. But the fact that we've got better visibility and that we're looking at instrumenting the network in a way that is cognizant of sustainability and energy efficiency, whereas before it was probably all about availability and performance. That is helping a lot to give us choices. And one of the things, based on just thinking about what Francis was saying, one of the things that I think we can do better, and I know a lot of operators are now being compelled to do this, is give information to the customers, give it to the consumers to try and help the consumers become more efficient users of services. So where we have older technologies that we want to sunset, or just simply less efficient ways of working that can be replaced by maybe different applications or different services, help the customer, help the end user, be it an enterprise or a consumer, help them understand, or if not understand, at least be compelled to start using the more effective, more efficient services where those opportunities arise. And again, that's kind of an instrumentation thing. It's giving people information, whether that's technical data for the technical users, or whether it's commercial data or whatever, to try and move people to be predominantly using the most efficient services or the most efficient hardware that exists at any given time.
Thanks very much, Nigel. Can we move on to the subject of AI now? Because this is a subject we are going to be covering every month this year, no doubt. How can telcos use AI and automation to make immediate improvements in areas such as energy usage? Francis, what's your take on AI?
I think the easiest thing to say about AI, take away the hype of it. At the end of the day, AI is about making decisions and analysis. It's hopefully a better way of doing that one. It may be less discernible why it's doing something, but that all comes down fundamentally to actually having access to data. So if telcos and telco suppliers want to use much more AI in their solution, it's going to be about much more exposure of data, probably exposure of data that goes beyond standards. I may need some data. I may need to make it easy for me to get hold of that data, even though I don't know I need that data. It's going to also probably involve a lot more collaboration on data. Quite often, the type, not to labor on large language models, but the type of amount of data that you need to make those work properly, as opposed to create garbage, is huge. That's going to require collaboration on data across potentially multiple CSPs. So data is a critical area, but if there's access to that data, collaboration, openness on that data, there's undoubtedly huge gains that can be made in AI here. The second point, which is again, I think, absolutely critical, is what do you do with that data? And that comes, particularly for energy, it comes down to having the control points to make decision, make policy, or change policy on the various technologies that we're using. How do we switch something off? How do we make an Intel processor go into a P state or a C state in terms of its usage of things? All of those control points need to be exposed in a way that the AI can use it. Otherwise, it's just informing us a better decision that we can manually tune. And the third thing I think we need to look at is we're an industry that's very heavily, and understandably heavily, bound by standards. But a lot of the areas that we will be discovering in AI will be a little bit grayer. They will be, if you're this type of operator, you may want to implement different policies. So you'll need to have that means by which you can bring a change in policy. To give a very specific example, a national network needs to deal with people in trains traveling at, say, 200 kilometers per hour. A RAN for a port doesn't need to deal with things moving at that speed. So there's options to be able to optimize the energy of what you're doing in the baseband in an open RAN for a RAN for a port versus what you have to do for a national network. You need the control points in which you can make those kind of decisions, remove functionality, add functionality.
Absolutely. Thanks very much, Francis. And as we heard last year on one of our summits about data and the need for commonality in data models, and there seem to be concerns there amongst our panelists, and this kind of plays into the AI space as well here. Terje, what are your thoughts about the role of AI, ML, and automation to help with energy efficiency?
Yeah, no, we have been working with on AI and machine learning on a number of areas. So just say some example is of course the RAN or the radio part of it. Another area is data center, and it's a bit linked back to I think what Nigel was discussing and Mark was discussing on doing the compute when it's best to do it also in terms of energy. And the climate impacts in that sense. I think then we're also using AI for assessing and bringing into the algorithms what is the mobility and traffic demand patterns, as these are changing both geographically and also over time. So that's another area where we have been using artificial intelligence. Then maybe diving into a detail, but for example, one question is what is the optimal time to replace a battery? Then of course it's important to understand how a battery works, and by doing optimizing this, there is quite a big benefit both from the climate definitely, but also on the battery capabilities. So also then of course the energy efficiency, and if you're going into a real radio site, you typically find multiple energy sources, and these need to be balanced. So that could be, for example, a windmill, or they could be a battery, there could be some grid, there might maybe some diesel generators. Hopefully not everything on every site, but at least there will be a mix of this on different sites. Then it's important to understand both the history and also the future, future demand. For example, take a solar panel. It's good to understand, when the sun is up, and when it comes to a windmill. Okay, so what's the forecast when it comes to the wind, for example, and to take that into account to decide on the battery discharging, recharging cycle. So a lot of intelligence which goes into to try to optimize across all these energy sources. But I think it's fair to say, of course, at least in Telenor, as I said, 90% of our total energy comes from the network, and out of that, roughly 3/4 goes to the radio part of it. And I think Mark discussed this earlier as well in this session. So we have been running AI across multi-technology and also multi-spectrum band on the radio, meaning 2G, 3G, 4G, 5G, and also you have low spectrum, mid spectrum, high spectrum, and so on. And being a very conservative and with very low risk, we could save roughly 10% of the total energy consumption for a number of samples where we're running there. So not doing a very aggressive energy consumption action. There are still some benefits to get out of that, and I think it's important to when you discuss the risk part of it, that many of these sites are multi-technologies. So you have 2G, you might have 3G, you might have 4G and 5G, and you have a lot of spectrum bands also deployed. So typically, you keep the 5G on the low spectrum or 4G on low spectrum and also 2G on low spectrum alive during the low demand periods, and then you can switch on the capacity bands and also the capacity technologies when that's needed. So that's a way you also could achieve fairly easily 10%, I think, of compared to a benchmark where everything is on.
Thanks, Terje. And that equates to a large amount of money as well. It's a significant amount. And I'm sure we're going to hear many, many more examples of AI applications with energy usage in the year ahead. Mark, let's come across to you now.
Yeah, just a couple of very basic ones, simple ones that we're looking at. One is using machine learning, using some of those techniques to focus on utilization. Being in the backbone space, we're keen to make sure that all of those links are keenly utilized. And so utilizing some techniques in that to predict and to plan utilization and get better utilization across those links helps us with that overall energy utilization across the network. That's one particular area. When I look a bit broader than just energy consumption of the network, I also look at some of the AI ops techniques that we've spoken about in the past that we use to minimize site visits and truck rolls and those sorts of things, which overall are contributing to reducing down our carbon emissions as an entity into that. So, just a couple of very simple examples where these sort of techniques can make an ongoing operational benefit.
Yeah, thanks very much, Mark. Great examples we're hearing, and as I said, we're going to hear a lot more in the year ahead. But from usage examples to sort of hardware, software innovations now, what are the new network technologies that are available or coming and about to be available that could help with the green network evolution? I mean, we've just on the RAN alone, for example, we've been hearing about the amount of energy that gets consumed in just the RAN, the radio elements of a network. Nigel, what are you seeing in terms of hardware, software that could be beneficial?
Yeah, so picking up on exactly that, as Terje said, that 75% of the energy consumed is associated with the RAN, so that's an obvious place to go looking. And it's also, I think for me, that's the most exciting thing that I've been aware of or involved in over the last year, 18 months or so. In particular, the development of Open RAN, the emergence of the RIC, the RAN Intelligent Controller, and being able to use that RIC as if you like, a point of flexibility or an interface between what's happening in the network and then all of these exciting AI-driven applications, XApps, RApps, that can then process data, develop solutions, give answers to be pushed back down into the network. And so I think that there's a whole load of activity going on around how RAN will be built going forward and how it will be operated, and that, I think that's the AI piece. If we stay on that for a bit in the RAN, there is very much an operational aspect to that. So being more efficient. I think Mark said, about truck rolls and so on. If you can bring up services and configure them and they work first time, and you don't need a truck roll or you don't need somebody to go to site to configure things, a lot of that can be assisted with intelligence that can look at deployments and configurations and the operational aspect, the day-to-day operations. And then the flip side is using the technology to deliver better quality of service or better user experience. So there's lots of innovation happening, in particular in the RAN, but we're also seeing it in other parts of the network. The edge, as I say, is a big theme and a big trend at the moment. There are things we can do there. And in the core of the network, again, I'll come back to instrumentation. The ability to start to instrument both the software and hardware elements, and then create data models around that and apply AI techniques to that in order to create decisions and to understand the network in a way that we've just not known it before. It's opening up huge opportunities. But in terms of innovation and where I think the most exciting stuff's happening, I think that has to be the RAN at the moment. There's a lot of net new capabilities happening there, whether it's operational efficiencies, spectrum efficiencies, user experience, a lot of creative ideas, and it's all coming about through things like having points of flexibility like the RIC, and then a growing ecosystem of vendors, smaller vendors that can come with new ideas and release them in the form of apps that can be integrated as part of an ecosystem. That whole environment is generating a lot of innovation, and that's, to me, that's the area that's most exciting right now.
Yeah, absolutely, Nigel. Lots of excitement around the RAN, which, as we've said, is such a huge consumer of power. But Mark, if I can come across to you first for our next comments, because you've got a network that doesn't have the radio access element. What innovations are you seeing?
Well, I'm hoping for trickle down from that RAN because it's such a huge consumer in terms of network terms. So that to get some of those techniques, particularly around the I mentioned it earlier, the 0 watt 0 bytes sort of approach, and how some of those things can trickle towards the core, towards the backbone. But one of the things that we're trying to develop as part of our overall value proposition within ConnectiviTree is the ability to route based on energy efficiency metrics, which means that those metrics still have to be defined and those sorts of things, but utilizing some of that. We're used to routing on latency and things like that. But when you're talking about long distance networks, which is kind of the space that I'm in, then can we put in some ecological based metrics that allow customers to make green based choices? And we're also trying to work on some innovation to produce some credible statistics and insights back to that instrumentation piece that Nigel spoke about, to allow then our customers to make more informed choices, and also to leverage some of that towards their own scope 3 requirements, and particularly as the whole industry moves towards net zero at the back end of this decade and into the next decade. It's that longer process. So we're looking at instrumentation that will allow that to take place. But I'm also keen on some of those techniques and things that happen in the RAN, because it is such the largest consumer of power, to have that, or energy, to have that trickle into other parts of the network infrastructure.
Oh, that's interesting, Mark. Yeah, the work being done with the RAN in mind, but that work will trickle down into other aspects of the network. Absolutely. I'll come to Terje in a moment, but Francis, let's get your thoughts now.
We've mentioned a couple of things, but I think one of the most important things that's going to affect energy is actually the increasing move to actually truly cloud native, running networks on truly cloud native disaggregated hardware. I think it gives a huge number of opportunities for scaling, healing, and breathing, I would say, and it disconnects us from being tied to a function at a box, which is largely how the network is at the moment. So that gives you a huge number of opportunities to think about when do I switch things off, when do I move loads to maybe more centralized locations at late in the evening when there aren't huge demands on the network. How can I breathe in, breathe out in the network? That is enabled by effectively a cloud network. The other thing I would emphasize is the increased ability to the data story. You can only control what you can observe, and a lot of the new technologies in terms of observability coming from IT and wider deployment in the network, I think are going to be very, very critical in terms of enabling more energy efficient networks. And the third thing I think we need to work out, not everything in the network is going to be, our recent Silicon report, highlights it. Not everything in the network is going to be based on Intel infrastructure. There's still a need, and I think the biggest technology sort of leverage for energy efficiency is going to be increasing improvements in silicon and silicon efficiency and energy efficiency attributes within that silicon.
Yeah, more bespoke telecom silicon as well. Yeah, spot on there, Francis. Thank you. And Terje, let's get your thoughts on this point of where we're seeing network technology innovation, whether that's hardware or software.
Yeah, no, we see innovations on multiple levels, and maybe can talk through a couple of examples. So starting with the basic ones, maybe is just a simple fact on newer chips, where the development from 7 nanometers to 5 nanometers and now 3 nanometers, resulting in higher capacity and lower energy consumption, which is relevant for all the network domains. Back to Mark's point as well. Then we also see the advancements on placing processing and processors in lower power state. or slower clocking rate, for example, with effect, of course, also on the with the lower energy going to processing, for example. And we also see innovations on faster moving between different states. So it's quicker to move from normal full processing capacity down to almost zero, and the other way around, which is important in order to control the risk, what we talked about earlier. So we are quick to respond to, for example, a spike in the demand when that's needed. And we also see innovations on understanding the traffic, for example, so you can process the traffic, whether that's meta data or the user data, or that we can also argue and to have a better understanding and avoid that unnecessary traffic is actually carried too far. Then, in particular, on the radio side, there are innovations on the more advanced antenna systems. So, with effect to emit energy only in the directions where the active users are. So you don't, send energy in all the directions, all the places, but only towards the active users. And of course, this would have an interesting effect on the reduced energy, but also need to keep a flat or broader coverage with a lower capacity, of course, for everyone. But it's also then, of course, important to understand in a three-dimensional what is the coverage need and where the users are. So that needs to be understood in three-dimensional. I think the RIC, what Nigel mentioned, that is, of course, one component to understand that. Then I'm not giving up on the shifting traffic to the newest technology. So definitely shifting traffic to 5G, for example, is contributing a lot. And that is, I think it was commented earlier in the session, that is typically a multi-year project. So it's not something you can do from one week to the other, but you need to talk this through with the different devices and also the different partners and definitely also the customers, and be clear on the communication of what you want to do, and also follow up with the information as we go along. And then, of course, linking that back to AI, because then you need to understand how the customers are moving. So you need to gather that information so you can do this shift to new technologies according to what the users are also upgrading when it comes to devices, for example, and also the applications, what they're using.
Great, thanks so much, Terje. I mean, with hindsight, when we look back, 3G is so terribly inefficient compared to what we have today. And also some of the use cases and examples you mentioned there, we will look back at some point and say that was obvious, but it's not at the time. And it does require a lot of effort to see these things through. Well, we are reaching the end of our program, but I do have one final question I'd like to put to you. And that is, when we look ahead, how can we better plan for new architectures and new processes that will see much more dramatic levels of improvement in energy efficiency? Mark, can I start by asking you, what are your thoughts as to what is needed here and how perhaps we should go about it?
I think what is needed is new thinking, and moving away from some of the legacy thought patterns, legacy concepts that we had in terms of how to approach network build, expansion, those sorts of things. Obviously I'm speaking with a vested interest because of the nature of the business that I'm in, but the idea of shared infrastructure just seems to make a whole heap of sense in certain parts of the network to be able to make that network more efficient. And it's efficient in terms of utilization. It's efficient, therefore, in terms of energy consumption, and maximizes the benefit of the latest and greatest technology that we spoke about. So I think it's new thinking, I mean, we've dabbled in shared infrastructure models over the years, but still, as an industry, we compete and battle with each other on the capabilities from a network and an engineering point of view, and perhaps we need to think a little differently about that to make some really radical and fundamental changes in the overall energy consumption piece. And this goes back to the discussion then about, the whole transformation to a DSP, and focus on the customer and things like that. But in the background there, on the engineering, on the technology thing, it does beg the question whether we should approach the future slightly differently, and more collaborative models, different business models, different approaches.
Yeah, absolutely, Mark. Yeah, new thinking. Francis, new thinking required. Anything else required from you?
Yeah, I think there's an important role for regulation here. Mark highlighted it. At the moment, we probably somewhere on the North York moors with hardly anybody there. We have four networks at the moment supplying power to an area where there is nobody. There's opportunity to share. That requires a different regulatory requirement. I think the second thing is that I talked about scope 1 and scope 3. We need a better way of bringing both those equations in. It's all very well at the moment. Actually, telco does a very good job of offloading me onto my Wi-Fi network in order not to use its power. So I'm not connected to the 5G at the moment. I'm connected to my Wi-Fi here. So Wi-Fi is permanently on. There's not very many energy efficiency there. It's provided by a telco, my router here. But we're not comparing what's happening there. What is the overall package of me having a Wi-Fi on permanently here, 24 by 7? So that ability to bring in the calculation across not just the scope 1 of what the network uses, but also what the scope 3 is of what the consumer uses. And let's be honest about it. Let's bring the supply chain into the scope 2 energy uses as well.
Yeah, thanks, Francis. And as someone who lives on the edge of the North York Moors, 4 networks maybe, but not all the networks at all the time. I guarantee that. Terje, let's come across to you, and then we'll go back to Mark. But Terje, what are your thoughts as to what we need to do for longer term thinking?
Yeah, no, I think we need to challenge ourselves. What was said earlier as well. So I think that's important to always work on improvements. And I think that goes across a number of topics. Architecture, goes of designs. It definitely goes on collaboration. I think was mentioned earlier as well by Mark. And just maybe a point to Francis. We see in our market at least that operators tend to collaborate, either in terms of joint venture, for example, or in terms of wholesale. So the operators can collaborate to avoid that. You have typically, 4 independent networks. You can maybe have 2 in a number of regions. So that can happen, by the operators themselves. But I think the collaboration goes a bit longer. And I think a discussion we also have been talking about here in TelecomTV maybe a couple of years ago is around application and content aware networks, and also network aware applications. And if you start to talk about, what is really needed to communicate and how critical is it to be always on for all applications, there might be something there to be, to make sure that we not are having all the lights on all the time. And we can definitely, shut off some of the radios during some of the periods, and maybe be even more forcefully in that way. Then I think also back to what Francis mentioned earlier, we see today even that a number of enterprise customers, they ask us for energy consumptions, which goes into their climate budget and accounting what they have to do. So they already have this on their agenda. But I think it's also important. I think perhaps it was Francis or Nigel mentioned that earlier, that at least GSMA did a study a couple of years back, and they said that the energy consumed by the telco industry typically helps to save energy in other industries. So the total consumption and the total overview on how the energy and the climate impact comes together, I think is important. So we not are zooming into one of the sub problems and forget about the totality and how much we can all gain together when we're collaborating.
Yeah, absolutely right. Thank you very much, Terje. I'm going to come to Nigel next, and then Mark, I will get back to you at the very end, but Nigel next.
Yeah, just very simply, I think I love the new thinking. I'm going to adopt that. I would talk about embracing the culture, etc. But I think if operators can embrace that new thinking, can continue to develop skills, which they've been doing a great job of over the last 5-10 years at least in this sort of space. I think that really thinking about the attitude to risk, a lot of these moves require you to change your attitude to risk. We're not in an environment now where you always provision for maximum load, right? You have to reanalyze where the risk is and treat it respectfully. So where you do have user plane functions, low latency, high performance, whatever, fine, allocate the capacity. But there's lots of areas in the network where, as I say, CPUs are running at 25%, and those can be turned down, they can be put into sleep modes and so on. So rethink the attitude to risk, I think, is a big part of it. And trust the machine. That's probably the hardest, is just trust the machine as we go forward.
Thank you very much, Nigel. Mark, you coined a really popular term there. I love it. New thinking. Final comments from you.
Well, Terje there and Nigel just gave a couple of examples of that new sort of thinking, which I really like. That ability, that always on sort of piece. Do we really need that? It's really intriguing there. I think that's a good point. The other area that, just we're used to operating our networks at a certain temperature, for example. Something just as basic as that. Can we up the temperature a little bit and run our equipment slightly hotter? Those sorts of things. I know it's being looked at and then it's being worked on, but that then has a major impact onto the other area. We've talked a lot about energy consumption by network equipment and things like that, but cooling, massive piece, and there's a lot of innovation going on in that area then. But just these minor adjustments in terms of our thinking about how we operate, how we run, how we build networks can make a significant difference going forward, as well as the processes, the collaboration, the different approaches to how we actually work as an industry. But we have seen that we've already made great strides, and I'm glad Terje mentioned that in terms of how we contribute to then the wider global economy in terms of reducing overall greenhouse gas emissions, etc. I think that's a good point to bring this part of the discussion together, and I'm sure it'll come up in other parts of the summit.
Yes, it was a great point to bring up there. Good point to end on as well, because we must leave it there for now. I'm sure we will continue this debate during our live Q&A show, though. For now, thank you all so much for taking part in an absolutely fantastic discussion. If you're watching this on day one of our Green Network Summit, then please send us your questions and we'll answer them in our live Q&A show, which is coming up very soon. The full schedule of programmes and speakers can be found on the TelecomTV website, and that is where you will also find the Q&A form and also our poll question. For now though, thanks for watching and goodbye.